Thanks everyone for attending. My name's Angela. I'm a software engineer at Pivotal. I work on Cloud Foundry, particularly the networking team, which I'm currently anchoring.
I'm Dave McClure. I am also an engineer with Cloud Foundry, and I was on the team with Angela when we were building some of the networking stack earlier this year.
And today we'll be talking to you about Cloud Foundry networking, in particular, enabling direct communication for your microservices. So let's just start with a brief overview of what we're going to talk about here today. First, we're just going to look at sort of something that a lot of you might be familiar with, going from Monolith to microservices, and then diving deeper into looking at microservices and some of the challenges, particularly communication between your microservices and how that works on Cloud Foundry. We'll then do a deep dive into the networking stack on Cloud Foundry before looking at how you can utilize container networking features hand in hand with Spring Cloud services. And we'll finish up with a demo showing you how simple it can really be.
Cool. So in the beginning, you have a monolith, maybe a majestic monolith. And your application handles a request from a user. You handle some business logic, and your application return a response. And things are good. It's a single code base. You can deploy it as a single unit. And there's no messy inter-process communication to think about. But there are some trade-offs here, right? And one thing that I think it's the most compelling reason to look at other architectures is it makes it more difficult when you have a monolithic code base for multiple teams to collaborate. So it puts some pressure on how you're able to scale your organization. The modules that make up your application cannot be deployed independently. So you have to do this kind of lockstep deploy if you have some ability to have different teams working on different features in your application. And in addition, it's a lot easier to kind of accidentally entangle the code base and have unwanted interdependencies between these components in your system. So these reasons and more is what's been driving the community over the past couple of years to really adopt microservice architectures where you may have a single request come in, and that may fan out to many other services behind a backend that ultimately return a response to the user. This now allows independent teams to develop and deploy these services. And on a system like Cloud Foundry, deploying these services is as simple as CF push. Another benefit, potentially, is that they are smaller, generally, these applications, so they're easier to test. The logic that's contained within any given application is a lot easier to reason about. We can develop and run them independently, and this allows the organization to scale to many teams, which is ultimately what's really driving us here. But distributed systems are hard. So you have a platform like Cloud Foundry that's already been solving a number of these problems for you. And in addition, maybe some of you today are already using Spring Cloud services. If not, I think we're going to give you some reasons why you should.
So as we said, distributed systems are hard. And one of the problems we really want to focus in on during this talk is how exactly these microservices are communicating, right? We see all these arrows in this diagram. All these microservices have to communicate with one another. So let's focus in on two microservices and a simple connection. Let's call them a front end and a back end, right? Something pretty easy to reason about. So with Cloud Foundry, you have the internet, you have your private cloud, and you deploy CF somewhere inside of your private cloud, right? And inside of your Cloud Foundry installation, the front-end app and the back-end app live. So we have these two different microservices, and obviously you want your front-end to talk to your back-end. So how exactly in Cloud Foundry does that occur? Well, in the old state of the world, say about a year ago, something many of you might be familiar with, if your front-end app wanted to talk to your back-end app, it would have to send a request all the way out to the internet, have it load balanced back into your private cloud, and have it directed to the Cloud Foundry router, which would then finally send it to the backend app. And this makes us pretty sad, right? Especially for two main reasons. The first is just even looking at this diagram, you're like, why are there so many arrows? Why can't I just draw an arrow between my front end and my back end and not have to go outside of my Cloud Foundry? We're introducing latency costs here by having to send all traffic out of my Cloud Foundry only to have a hairpin back in. The second reason that this makes us sad might not be as apparent from this diagram, but centers on security, right? Because in your Cloud Foundry, all of your applications are running on containers, and we schedule these containers on different VMs to optimize your workloads. So that means you don't necessarily know exactly where your front-end app is living or where your back-end app is living. So to allow traffic from your front-end to your back-end, not only do you don't know where it's coming from, so you have to allow a wide range of IPs to be able to hit the back-end. And B, since it has to hairpin out from the public internet back in, we see that we also run into the issue of having to have every app that you want to have traffic sent to have a public route. And if your backend app has sensitive information, this isn't a great security story. So luckily, I said this was the old state of the world, right? It's not the current state. Now we can have this simple line between your front end communicating directly to your backend app. And this is enabled with container networking. So container-to-container networking is allowing this direct communication between your microservices. Your traffic doesn't have to leave your Cloud Foundry. It's introducing lower latency, and also now your apps don't need public routes. We're allowing you more fine-grained access for your applications. So let's take a deeper dive into the networking stack. So I like to think of networking in two parts here. One part is the connectivity, how we're actually having the direct communication. And then the second touches more on the security aspect. How are we actually enforcing what in your Cloud Foundry can talk to one another? So connectivity. How are my packets actually flowing? Well, with the container-to-container networking solution, we introduced a VXLAN overlay network. So this is a network that's on top of your physical network, as long as it's a private range that doesn't conflict with anything else in your Cloud Foundry deployment, you're good to go. And every single container that's created in your Cloud Foundry gets a unique IP from this overlay network. So the entire overlay network is based on layer 3 traffic, so the IP layer. So no two containers have layer 2 connectivity with one another. We're doing everything via IP level. Now, obviously it's great that your containers can communicate with one another, but you don't want any application in your Cloud Foundry to communicate with any other application, right? That's, again, not a great security story. So we also introduced, in addition to connectivity between your containers, policy. So by default, all traffic between containers is denied. So this is really important in the case of a multi-tenant Cloud Foundry. You don't want other people's apps to be able to talk to your apps. But even in a single-tenant Cloud Foundry, you might have an app that's particularly sensitive, worked on by a specific team, that you don't want others to be able to access. So we do policies on an application level abstraction. So you set policies from a source application to a destination application. And every application that's part of a policy will get a tag. This tag will be encoded in the VXLAN GBP packet header, and we'll use this tag alongside IP tables to enforce whether or not packets can go from the source application to the destination. I realize we might have different levels of networking experience here, and I just threw a lot of different phrases and terminologies and words at you. So let's take a look at a diagram that sort of puts the connectivity story together with the policy story. So let's look at how packets are actually flowing. So here we have 2 different hosts, 2 different VMs, and 2 different applications, 1 on each. So let's look at how traffic flows from app A to app B. So assuming that a policy is allowed between them, well, actually, even if a policy isn't, we initially send a packet from app A to app B with the source and destination IPs being the source and destination container IPs, so the IPs in the overlay network. When this packet goes from the source container from app A into the VM, we will encapsulate the packet. We'll put the tag associated with app A into the packet header, and we'll put a new source and destination, being the source and destination of the host VMs. Then this packet can leave host 1 and will be routed to host 2, where it's de-encapsulated. This is the point in which we check whether or not we actually will allow this packet to continue. Have we configured a policy for it? If we have, then we'll allow the de-encapsulated packet to travel forward. And if not, it would be dropped. But in this case, assuming we've configured it, it will reach the destination app, application B. And so that's sort of a little deeper insight into how the networking stack is set up. But just because my apps can communicate with one another doesn't solve everything.
Right, so as Angela mentioned, each of these containers gets its own IP address. And we simplified the drawing with 2 circles to show application A and application B, but you can actually have multiple instances of each application. So containers are coming and going, each having its own unique IP address. How does application A find an instance of application B to send this packet to in the first place? Previously, in the old hairpin diagram, you got that feature from the CF router. Now you have to get it elsewhere. So here's app A trying to reach app B, and the solution is you can bring your own service discovery. There's many tools available to do this. There's things like Amalgamate. There's Eureka, an open source project from Netflix. And Eureka has actually been integrated into Pivotal Cloud Foundry as Spring Cloud Services. So this is what we're going to show you today, is how you can use Spring Cloud Services to bring this service registry into the equation here to let application A find application B. Spring Cloud Services is something you should definitely check out. It's not just for service discovery. This is just pulled from the website. Spring Cloud provides tools for developers to actually apply many patterns that are kind of necessary when you start building distributed systems. So things like circuit breaking, service discovery, and many more. We won't go into all of it today. We'll just talk a little bit about how you actually use these features together here. And getting down to the mechanics of it, you first create a service registry using CF create service command with the CLI. You bind your application to that service. This can be done again with the CF CLI or with the manifest of your application. And then within your Spring application, enabling your application to communicate with the service registry is as simple as adding this annotation to your application class and setting a couple properties. This is important, so I'm going to pause here for a second and just call it out. This registration method direct is what tells your application to register with the service registry using its local IP address as opposed to its route. So if you are using Spring Cloud Services today, you may be using a service registry, but you're likely having your application register with its public route. And in the future, you won't need this public route. Instead, you'll have to have it register with its IP address. So we're going to actually take a look at this in action. So here I've got, I hope, still targeted, and let the internet gods bless us, an app running on PWS, so named front end and back end. And you can see I've got 3 instances of back end and a single instance of front end. The front end application has a route, the back end does not. And the way that this is actually implemented, I'm just looking at the front-end application. I think it kind of illustrates the story. On the left here, we've got our front-end application. It's annotated with enable discovery client. I've gone ahead and added a controller directly into my main application class. And it's going to handle requests on its default route and make a call to the backend client to ask for cats. When it gets a cat back from the backend, it will add that to the model and show it on the page for us. So our backend client, how does that look? We've got another Spring Cloud annotation here, enable circuit breaker. And the circuit breaker annotation lets us add this hystrix command to our cats method, which tells it there's a fallback method. If this cats method throws an exception, either because my backend is not available at all, or maybe it's overloaded and returning 500s, then call this other method instead called dogs. And so if our backend fails for some reason, the front end is just going to give us a dog instead. So we've got these applications running. And here's my view through the PWS portal of my circuit breaker and my service registry. So I'm going to go ahead and click through and just show you these as well. So I've got both apps registered, and I can see that my backend is registering with their private IP addresses here that are all in the 10 dot range. And if I go back here and look at my circuit breaker dashboard, I can see this hystrix dashboard, which is going to show me the requests from my front end to my back end. And if they're successful, this little green will light up. If they fail, the red will light up. And if my circuit opens, the blue will light up. So let's head back over here and just grab this route. Open a new tab here. And there we go. We have a cat. So I skipped a step here. And to illustrate this policy that we were talking about, we can see that we're able to access the backend because there's actually a network policy in place. So if I say CF network policies, I can see that I actually have a policy in place that allows my front end to talk to my back end on port 8080. If instead I remove this policy and then check again what network policies exist, there's now no policy in place for my front end to reach my back end. And I head back over here and I ask for another cat, and instead I get a dog back. And if I make multiple requests in a row, you can see the dashboard on the right, my number of failed requests going up. Eventually, it'll start giving up and not even calling the back end at all with these blue numbers showing me that I'm in a state where my circuit's broken. So I think that kind of demonstrates how your applications now can actually talk to each other without a hairpin, using Spring Cloud Services as a really easy way, especially if you're doing a Spring Boot Java app to wire in service discovery.
Question about Spring Cloud Services and how it works with container networking. Spring Cloud Services, Eureka supports peer replication across foundations. If you're using container networking, is there complications?
So the question was, if you have multiple foundations and you're replicating the service registry across those foundations, will that cause issues? Can I still use this feature? And the answer is no. You won't be able, you don't have an overlay network that stretches across multiple foundations. We'll take a few more questions. I just wanted to scroll through the slides that I skipped here. Just to reiterate, the policies, all traffic is default deny. So you would have to whitelist the applications to reach each other. the policies are based on applications, not containers. So you don't have to think about IP addresses. In fact, we don't want you to think about IP addresses. Think about allowing traffic from one application to another, and as you scale your applications, the policies that are implemented under the hood in IP tables will be handled for you. And you can configure policies through the API as well, which gives you a little bit more flexibility if you want to create policies between applications that are in different spaces, for instance. The API is a better use case for that, as well as if you wanted to drive some of this policy creation through automation that may be tied into other parts of your workflow. And as far as creating network policies, one other thing to call out here is that you can specify the port and the protocol. So we support UDP as well as TCP and any number of ports. So this actually enables you to also have microservices that may be listening on different ports for different services, or do more sophisticated things like that that you can now achieve with this new networking stack. There's our happy cat. And here's a bunch of resources that you can check out on your own if you want to dive even deeper into this. More info about Spring Cloud. The CF networking stack is open source, so you can look through the source code of that, as well as the Silk CNI plugin that we implemented. And if you want to give us feedback, the best place to do that would be to go to Cloud Foundry Slack channel and join the container networking channel, where the entire team is available to kind of answer your questions and learn more about your use cases. So our call to action is try it out. It's available on PWS, as you can see. It's available on your own PCF if you've got PCF 111 or above. And there's a couple other sessions coming up that you should also check out as well. So immediately after this, in room 2007, there's a deeper dive on Spring Cloud Services. Tomorrow, there's a talk about Cloud Foundry networking with VMware's NSX service, software-defined networking solutions. So we provide kind of built-in version, but NSX is really cool. You should check it out as an alternative. And then for an even kind of further view into the future, the possible future, there's Ramiro's talk on Istio next afternoon as well. So at this point, if you guys have any other questions, I think
Yeah,
Angela
we're
can take
open to questions now. Thanks. Yeah.
Question about configuration. Does the network policy support manifest?
No, the network policy currently doesn't support configuration through the manifest. Any other? Oh,
right
yeah.
there. It's a little hard for us to see with the light, so do it like I did and wave. Good.
Is there a finer range of configuration in policies such as, say, this app can also to these elements, the other apps? Is there something like that, or is that something for the future?
So the question was, is there finer grained policy at the level of like the route on each app? So this app can only access this other app at a certain route or path?
Certain endpoints, yes.
Certain endpoints. There's no such feature today somewhere. It's really all operating at layer 3 and layer 4, not layer 7. So we're not, the policies are not route aware. They're only aware of port and protocol. And the waving
okay.
back there.
Is there any difference in how this structure works depending on which IaaS you're running on? So if you're running on AWS or vSphere, it's all the same?
So the question was, does container networking work any differently? Is it IaaS dependent? The answer is no. Should run the same on AWS as it does on GCP, as it does on vSphere.
And right in front of you, did you have a question as well?
Yeah, I was going to ask, is there an easier way, so if I recall correctly, I think that demo is HTTP and not HTTPS, right?
I don't even know what I just did there. Probably.
Is there an easy way to set up a Spring Boot application that uses certificates for that container networking if you have a requirement to not use straight HTTP? Is there an easy way to configure a Spring Boot application to communicate like that?
On the Spring Boot side, it's been a while since I've gotten paid to write Java, so I don't have the best answers there. I'm pretty sure you can deal with certificate management pretty straightforward by setting like your trust store or something like that. As far as what the platform's bringing on TLS, do you want to speak to that a little bit?
So we're looking into having more layer 4 solutions in terms of like policy enforcement, but that's a little bit further down our roadmap.
Yeah. So for instance, there's been some work to like have certificates per application or per instance automatically kind of injected into each application container, but how you leverage that today, I'm not sure. But it's a great question to follow up with in Slack.
Yeah.
Behind you?
Yeah.
Question I had was, can we make this work with a standalone Eureka instance rather than managed service?
Yeah, there's actually another thing to check out. The link to the container networking repo has a folder of example apps. And one of them does just that. It just uses plain old Eureka. And there's another one that uses Amalgamate as well.
Yeah, so if you look at the repo, we have many different apps utilizing different service discovery solutions.
Got one way in the back.
Can you go back to slide?
Sure. Cool.
Route services, are those bypassed in container container?
I believe
Yes.
they are.
So
right?
the question is route services bypassed in container to container networking? And the answer is yes.
Your example is that free method services, which ID you choose is based on registry.
So the question was, how is the instance chosen among the three instances that are, the three backend instances that are running? And that's brought by Spring Cloud Services. I believe under the hood, I could be wrong. Ribbon, I think, is the technology it's using to kind of do the client-side load balancing. So it's happening client-side, that much I can tell you. Right here. I'm sorry, the backends. Can we deploy the backend services in different AZs is the question. And I don't think there's any restrictions there. All of the Cloud Foundry itself is multi-AZ. So all of your instances actually will be spread across multiple availability zones. And that is not going to get in the way of the networking stack. No, it will not use the router. It will, the IS routes between those availability zones without a problem. So it's just going to be in the slide that Angela showed with the cells sending the packet across and the encapsulation. It encapsulates the packet leaving one virtual machine with the source IP address of that virtual machine and the destination of whatever other VM it's destined for. And that packet will reach its destination across availability zones. Right here.
So if you did have an overlay network that spans across multiple combinations, and you have policies between services and combinations?
So right now, so the question was if you have multiple foundations, can you have policies that span across? So right now, container to container networking doesn't support the multiple foundation use case. Right there in the, yeah.
So just to make sure, so container to container networking, like the mental model is kind of like a way of putting all apps in the same VLAN, and they can all communicate within that VLAN with the traffic codes. They can come in from the outside or outside if you wanted to configure it that way, but it's essentially they're living on the same subnet, and now they can directly talk to each other. There's no need to go out to the optical router to come back to them.
Yes. Did you, wait, I think
Go
he's
for
had a
it.
question for
I was
a
just going
while.
to check the time.
Slides mentioned the registration method direct with the demo app. I didn't see any reference to that.
OK, so the registration mode, where are we actually setting that? I should be able to find that pretty quickly. That's in the backend application. You have your application properties. In this case, it's in YAML. You can do the, so here's the registration mode.
So I think we'll take,
So is this available today?
Is this available today? Is that the question? Yeah, so right now you can be using both container networking and Spring Cloud Services on Pivotal Web Services or in PCF 111+.
Cool. Thanks so much. I think that's...
Yeah, we'll stick around. We'll probably go just right outside the door to answer any further questions, but we want to vacate this.
Thank you.